We're going to cover 4 different types of data. The first one is probably the main type of data that you're going to be exploring, which is quantitative data. There are 2 categories for quantitative data, and the first that we will look at is discrete quantitative data. Discrete quantitative data will be numbers like ages and quantities of things. Numbers that we do not normally associate with as non-whole number units. Our example here is a vector of randomly generated ages. We're going to say this in the variable age. A large portion of your job will be putting this data in a graphical format that our sponsor easily understands. I will show you some ways to visualize each of these different data types, starting with the numeric discrete data. You can create a table of ages if you just want an aggregate count. We can extend the table out a little into a bar plot to see how many of each age we have in the data set. The bar plot is over here. If you have more than just a few numbers in your data set, you may wish to run a histogram instead of a bar plot. Histograms bin your data from 20 to 25, 25 to 30. They're very handy for larger data sets to collapse them. Another tool closely related to a histogram is a stem and leaf plot. Stem and leaf displays, plots, also known as stem plots, have 2 basic parts, stems, right here, and leaves. The final digit of the data value is taken to be a leaf, and the leading digit is taken to be the stem. We draw a vertical line, and to the left of the line, we list the stems. To the right of the line, we list the leaves beside their corresponding stem. There will typically be several leaves for each stem, in which case the leaves accumulate to the right. Now on to continuous data. Common examples of continuous data are lengths or time-based. We are going to work with 2 different vectors here. The dataset rivers is a vector of the lengths of major North American rivers. The dataset precip is a vector of annual precipitation in 70 U.S. cities. Here's what the first 4 observations look like in the precip dataset. There are a number of ways to display continuous data. A strip chart is a one-dimensional scatter plot. This is a strip chart. Here is one for the precipitation. The strip chart for rivers, we added the jitter parameter to the strip chart for rivers, so all the points just don't bunch up right here. We can actually see the spread. As with the discrete data, you can make a histogram of the continuous data. We can look at a slightly more complicated example of a time series of the water heights of Lake Huron. This is also continuous data. We now move to qualitative, categorical data, and factors. For this example, we will use the state dataset, which contains data on all 50 states. Specifically, we are going to look at the region that each state is classified in. I recommend using a table to display qualitative and categorical data. I think that's the best way to look at it. See down here, we see there are 9 states that are considered northeast, 16 are south. But you can also use a simple bar plot to show the counts of the data. Notice I had to put the table in here. I can't just put the data straight. Logical data is used in a true-false scenario. For example, if we look at the numbers from 5 to 9, we can calculate how many of those are less than 7.3. And so if we take a look at y, which is where we stored that, the first 3 are true and the last 2 are false. We can take a look at the opposite of that statement by adding an exclamation mark to the front of the y. So this is going to give me not. So it's going to flip this symbol, right? Finally, you're sometimes going to run into missing data. Let's look at these 2 vectors, x and y, down here. Both of them have missing values. It's important to note that R does not count missing values as zeros. If R counted NAs, which is our missing values, as zeros, you would have a value in each of these spots of vectors. But notice there's not. I'm missing these two because they had NAs in there. If we have NAs in our data set, R will not add the vectors also. We will get an NA returned. So we have to get rid of the NA using the NA.remove parameter, and it will add them up. It'll just ignore the NA. You can also do a quick check on your data sets for any NAs that are in there, or just remove them entirely from the data set if you want. And that will do the sum.